EarthEngine stack, and there are several different APIs, which I'll talk about in a second. Once you've developed your workflow in EarthEngine, you want to expose the results to the world. And so we provide an interactive app library on top of EarthEngine that lets you code up graphic user interfaces so that you can expose the results of your analysis to your friends and colleagues and or the world. Decision makers and policy makers can be influenced by the work that you do through these EarthEngine apps. Again, you can learn all about this stuff from the homepage of our docs. Okay, I mentioned there were several different APIs, and let me dive in a bit more to what those are. The main one is JavaScript, and I say it's the main one because we provide an online IDE, which we call the code editor. And the code editor is not only an editor for JavaScript, but it also gives you a map and a graphic interface that lets you browse your assets and browse the library and browse your scripts and a bunch of other tooling that gives you a fairly integrated development environment for JavaScript. Of course, you can also write JavaScript apps for Node. But if you're not a JavaScript programmer, we also have a Python API, and the APIs are virtually identical. So once you learn one of these APIs, you're automatically going to know the other one. The Python API is included in Colab. So it's in the default runtime for Colab notebooks. So if you are a Jupyter notebook user, you can fire up a Colab instance and just start using EarthEngine right away. So the Python is very easy to use as well. The JavaScript and Python libraries are client libraries, and I'll get into a little bit more about what that means in a second. But you can also make direct calls to the service by making authenticated HTTP requests using the library of your choice. So you can use one of the client libraries, JavaScript or Python, to formulate a request and send that request directly to EarthEngine through the REST API in order to get blocks of pixels or blocks of computed pixels, that kind of stuff. Can you still hear me?
Yes, we can hear you.
Excellent.
Yes, yes.
Okay, so JavaScript and Python client libraries, you can also make direct REST calls. Of course, we have docs for all this stuff. And that's how you connect to the service. But as I was mentioning a second ago, the real core of EarthEngine is the data catalog. And we've got lots and lots of stuff in the data catalog. You can search through it from this link. You can also upload your own stuff. So if you have your own data set that you want to analyze in conjunction with what you can find in the public catalog, you can upload that and it stays private to you. And you get a small storage space that you can use to store your own assets. But there's a ton of stuff in the public data catalog, and you just have to search through it to find what you want. If you can't find what you want, you can always make a request for a new data set, and you can find that request button in the upper right of the code editor. Example. First of all, where is it? I will pause while you consider what the answer might be, and then I'll reveal it in a second. In the meantime, what is it? This is a mashup of 3 different data sets that you can find in the catalog. So the red part is thermal from Landsat 8. The green part is near infrared from Sentinel-2, and the blue part is backscattering coefficients from Sentinel-1. And the point of this demo is that you can easily combine all these different kinds of data sets from different sensors, from different image collections, and develop these incredible visualizations and these interesting composites that you can use for analysis. You can download this, you can share it. Here is the link So I mentioned there are a bunch of links in this presentation that you might want. Here's a link to the code that generates this composite. So everybody who has these slides can get the same code and fool around with it and mash up any other data sets that you can find in the catalog. I promised to reveal where it is. This is Shanghai in China, and you can see the blue here is the tracks of ships going to and from the port. And you can see areas of the downtown that are hot, but also areas that are vegetated, and areas that are both too. So interesting visualizations and composites that you can make quite easily from the data that you can find in the public catalog. Okay, so that's the data. That's sort of the background of EarthEngine, the data, and now I just want to talk about the API a little bit. There are lots and lots of different ways to do things in EarthEngine. So I mentioned previously that there are JavaScript and Python client libraries, and the first two links that you see here are really just demonstrating different ways to get blocks of pixels. So what I mean by that is you can follow this link and discover a cloud-free Sentinel-2 composite centered at these coordinates, and you'll find a variety of different ways to get at those data. For example, you can display a thumbnail, you can get a download URL and download those data as well. But you can do the same thing in Python. So if you go to this Colab notebook link, you'll find a notebook that demonstrates really the same kind of things, except in Python, using the Python client library instead of the JavaScript client library. But the idea is the same. You can just get blocks of pixels if you know what you're looking for. And as I mentioned previously, you can do the same thing with the REST API now. So if you just want to go directly to the EarthEngine service, you can formulate your request, and this quick start shows you how to do that. You can send that directly to Google servers and just get an answer, hopefully get an answer directly from EarthEngine, but I recommend starting with the client libraries. You're going to need those client libraries anyway to help you formulate these requests. So start with the client libraries, but you can make calls directly to EarthEngine through the REST API if you want. And here's an example of doing that. This is just the link that I showed you a second ago, that JavaScript link. If you click that, you'll get, you can generate sort of these wonderful, almost cloud-free composites of your area of interest. So lots and lots of data, sort of really easily accessible directly from EarthEngine. What can you do with it? So we've got all this imagery, but there's lot, you know, one of the very common use cases of EarthEngine is just to train a classifier or to train a prediction algorithm to predict in a regression sense or in a probability sense. You can do all that stuff with the ee.classifier package. And we've got a bunch of classifiers in here. This is just demonstrating CART. But we've got neural networks and support vector machines and random forests and linear regression and all the familiar machine learning algorithms you can generally find in ee.classifier. Random forest is probably the most built out of those classifiers, and what I mean by that is that it can be operated in classification or regression mode, but also probability mode, and you can get vectors of predictions and all kinds of fancy stuff from random forest. But this is just demonstrating using a simple classifier here, which is CART. And all you would do is .train your classifier with your training data set, and this might come from interactive data that you collect using the code editor. You know, you can heads up digitize points. But it might come from a shape file that you upload, you know, GPS points that you collect out in the field. You can upload all that stuff and use that for training. And you just tell EarthEngine what bands you want to use to predict from your image. You select your image. It could be anything like that Sentinel-2 image that I showed you one slide ago. You can use that to classify. You select the bands of interest, you classify with the trained classifier, and you add the classified image to the map, and that is it. So how many lines is that? Not very many lines of code. What once took me a very, very long time to do this kind of thing is now, just a few lines of code in EarthEngine. So plenty of classifiers in the EE classifier package. There are also clusters in there. If you need unsupervised classification, see the ee.cluster package. But there's also more fancy stuff that you can do if you want to use deep learning with EarthEngine. So we support the TensorFlow library, and the way that works is you would develop your model using the TensorFlow library. You would host that model on AI platform. And the way that works is you can get your training data from EarthEngine. You can export that to cloud storage as a TF record data set, train your AI platform model automatically with the data that you've stored in cloud storage, save the trained model on a AI platform, host it, and get the predictions directly in EarthEngine from the trained model. So what this allows you to do is implement almost whatever model you want using the TensorFlow API, including deep learning models, convolutional models that will work on a patch of your image rather than a single pixel. So, you can take a patch of, say, 128 by 128 of as many bands as you want, or, more than 3 bands, and give that to a convolutional neural network in TensorFlow, and that is something that would be very difficult to do with, say, random forest in EarthEngine. But we do have this method for you to develop TensorFlow models, host them on AI platform, and then get your predictions directly through EarthEngine. And you can see our EarthEngine TensorFlow docs from this link to learn all about how to write TensorFlow models for use in EarthEngine. There are also some trained models that are out there. So, for example, if you go onto TensorFlow Hub, you can find a model that was trained on the Big EarthNet dataset. So Big EarthNet is a bunch of patches from Sentinel-2 that were annotated by a group. You can read all about that work from this link. But anyway, there are a lot of patches that have been manually labeled from Sentinel-2. That's called Big EarthNet. And a convolutional neural network was trained using the ResNet 50 architecture. And that trained model, so a model trained to recognize the Big EarthNet classes, is stored on TensorFlow Hub. And you can just grab that model and host it and get predictions through EarthEngine. So here's just an example of feeding this patch from this trained convolutional model to EarthEngine, and it predicts this label here. But the point that I'm making is that you can operate these convolutional neural networks in EarthEngine. Some of them you can even find already trained on TensorFlow Hub, and you can host those and get predictions from them. So using spatial context to get predictions, not just a single pixel. Compute. So how does all this work? I'm just going to pull back the curtain a little bit here. When you write code in the, for example, the JavaScript client or the Python client, what happens is your code gets turned into a special request by one of those client libraries, either the JavaScript library running in the code editor or the Python library that you would download to your machine. So you write a bunch of code, the client library turns it into a request. The request is sent to Google servers for processing, to EarthEngine. And EarthEngine will load up the image data sets that you want, load up the algorithms that you want, shard the computation over many, many machines. Usually that's done by tile. So the image is chopped up into tiles, and each tile is sent to a different machine for processing. And when you get your answer, the result is sent back to you for further analysis. So the result might be a tile that you display in the code editor. It might be a chart that you display. It might be a statistic or a table of information. You can also start long-running tasks. So that's generally called exporting in EarthEngine. Capital E, export, is where you can find that in the library. And so the request is just to start one of these exports, to start a very long-running process. And then all this sharding and computation can take much longer, and the result of that analysis will be materialized in your Drive account or a cloud storage bucket or in your EarthEngine assets folder. So that's how it works. The EarthEngine code that you write never actually runs on Google servers. It just gets turned into the request. The request gets sent to Google for processing, and you get the result back wherever you want it. It's worth noting that you can do this, as I said before, with the REST API. So you can make the requests directly. You don't have to rely on the client library to do it for you. But again, the client library will put the request together for you in the right way. It's guaranteed to be the right way, as the clients change and as the backend changes, the clients are kept in sync. So that's why it's good to make the requests from the client library if possible, but you don't have to. You can also use the REST API. So all that is detailed in this excellent paper by my colleagues from the EarthEngine team, and this is open access. You can read about this in remote sensing of environment, but suffice it to say, here is your code. That gets turned into this little expression graph, which gets sent to Google for processing, and then you just see the result of this graph. Okay, apps. All that is very fun and good, but let's say that you get through the result of your analysis and you've loaded data from the catalog, and you've loaded algorithms, and you've written a bunch of code, and you're very proud of your analysis, and you'd like to show it off. That is what EarthEngine apps are for, so that you can show off the results of your analysis to your friends, to your colleagues, to decision makers and policy makers at large. What you want to do is make your data sort of operational, or your analysis operational. And you can do that with EarthEngine apps. So we provide a bunch of code that lets you put together graphic user interfaces right on top of EarthEngine. And then those interfaces are displayed to the world via an EarthEngine app. So you can see some examples here at EarthEngine app, earthengine.app. And we have lots of examples in our docs, and of course in the code editor we have more examples for user interfaces as well. But I just wanted to highlight some of the interesting stuff that you can do, and I just checked these apps today. They still work, all of them, so feel free to check out these apps. This is an interesting urban heat island, surface urban heat island app that lets you go to various places in the world and look at how hot the city is compared to its surrounding environment, and you can quantify that with this fun surface urban heat island app. The intertidal app. This was a great publication done by Nick Murray et al. I think he's actually on the agenda here, so if you're lucky, you might hear from Nick Murray later. But this is the app that describes a lot of that work, and this was put together in part by my colleague Michael DeWitt. And check out this app to see a fun demonstration of not only embedding an EarthEngine app in a Google Sites page, but a bunch of fun UI widgets. For example, a little slider widget. This app is a surface water exploration app specifically targeted to sustainable development goals around water and water availability. So you can go to this app and explore surface water availability and change over time for your area of interest. This is an app wrapping an interesting surface water data set generated by Pekel et al. In collaboration with some of my colleagues at Google, and all this stuff you can find in the public EarthEngine catalog as well. This is just a fun app that I put together for demonstration purposes. This is just an NDVI inspector. So you can click on a point and you can get a spectrum at the pixel, and then you can get a time series of NDVI of that pixel over time. And the only purpose of this app is to show that you can make a map, and then you can make the map interactive by adding these charting widgets on top of it. So when the user clicks the app, you get a little chart of information. So the great thing about these apps is that not only can you expose the result of your analysis, but whoever is using the app doesn't have to see any code. So of course, with EarthEngine, you can always get a link to your code and share that around, email it to your friends and collaborators, and they can get the code and play with it and see the same map and all that kind of stuff. But you don't always want people to be able to see the code of your analysis. You just want people to be able to interact with it or use the map and not see the code. People see the code and they make a change and it breaks and they get confused. So anyway, it's much nicer to have these apps that you can build on top of it to have more control over the user experience when you're exposing the results of your analysis. So that's EarthEngine apps. Partnerships. We have a lot of partnerships on the EarthEngine team. As I mentioned in the beginning of the presentation, we have some fairly lofty goals about solving big environmental problems, and we rely on our external partners to make progress there. And so I just want to talk about some of our partnerships and how we see EarthEngine being important for actually solving environmental problems moving forward. So this is what we call the Environmental Insights Explorer, and you can find that at insights.sustainability.google.com. And this is intended to help cities make better decisions, specifically to help cities make decisions in order to reduce their emissions and to reduce their carbon footprint, for example. So we provide this kind of app. This is in fact built with EarthEngine. So Environmental Insights Explorer relies on EarthEngine, and the idea is that we're sort of exposing this dashboard, if you will, to cities that quantifies various data sets that we can have in the background and share with the cities. And the idea of this is to help cities make better development decisions. So this is one way that we internally use EarthEngine in order to achieve the kind of impacts that we want to have out in the world. And we're constantly adding new stuff to EIE. So here we have this a tree canopy layer for Los Angeles, and we're working on these tree canopy data elsewhere as well. But the idea is that cities want to know where they have trees, or more specifically where they maybe don't have trees but could have more. And so some internal Google data sets were utilized in conjunction with EarthEngine in order to generate these maps of tree canopy cover in various places in the world, and to expose those through the Environmental Insights Explorer in order for cities to make decisions. But the point that I'm making is that you too can build stuff like this. In fact, a lot of this stuff is prototyped with EarthEngine apps, and a lot of it is in fact EarthEngine apps behind the scenes. But this is an example of the kind of thing that we hope external users will be doing with EarthEngine apps, as sort of building decision support systems for people who might not understand about remote sensing or GIS, but still need this kind of information in order to make better decisions. So that's the idea. We're also using EarthEngine to develop a lot of experimental stuff, which may or may not end up in EIE, but let me just give you an example here. This is an air quality map. And so specifically, this is NO2 in parts per billion. And this was generated from a model. And specifically a model, a random forest model running inside EarthEngine, trained on millions of data points from all over the world about air quality. And you can generate these predictions. And these predictions can exist anywhere in the world. So that's, as I mentioned previously, one of the big strengths of EarthEngine is that you can sort of prototype your analysis in some local area, but apply it wherever you want, including globally. And so that's what this is. It's predictions of air quality made in EarthEngine using random forest, trained from data all over the world, but you can make predictions anywhere, including Singapore. This is not Singapore, but you can make predictions there. And that's the another example of the kind of data set that we might want to expose through EIE or some kind of EarthEngine app in a decision support system, if you will, in order for policymakers to make better decisions about cities. Supply chain stuff. Unilever made this fantastic announcement not too long ago about the partnership that they have with Google, and we've been working with Unilever to help them get the information that they need in order to make their supply chain not only more transparent but more sustainable. And specifically, they have commitments to reduce deforestation, to eliminate deforestation in large parts of their supply chain, and they're going to use Google Cloud and EarthEngine to do that. So we're starting to have some interest among commercial users who would like to use EarthEngine to improve environmental decisions, but in a commercial context. So big consumer packaged goods companies like Unilever and others are very interested in the geospatial data and the tooling that EarthEngine has that will let them analyze the data and bring that information into their business so that they can clean up their supply chains and help reduce deforestation in the supply chain and ensure that the products are coming from sustainable sources. So commercial users such as Unilever are starting to take interest in EarthEngine and specifically around supply chain, cleaning up the supply chain. National Geographic partnered with Google to make a better land cover map for the whole world, and specifically to make a map at a global map at 10 meters resolution of land cover for the entire Sentinel-2 archive. So every Sentinel-2 scene is classified into land cover, and this work is currently under review. This was done by some of my colleagues on the EarthEngine team, and they gathered many training data points and developed a convolutional neural network in TensorFlow that operates on Sentinel-2 images and turns every Sentinel-2 image into a land cover image. So this is a data set, a global land cover data set at 10 meters resolution, very high temporal cadence. We're very excited about this. It's not quite ready yet. As I mentioned, it's still under review, but we expect to make these data available to every EarthEngine user in the near future. And this is a direction that we are going to be going in on the EarthEngine team, is sort of building data products, if you will, using machine learning. So previously we did that by building, for example, cloud-free composites, and those are very useful to our users. You know, you don't have to build your own composite, you just go and get one and you can use it. And we hope to be building composites like that will help users just sort of pick up some imagery and start doing meaningful classifications, that kind of thing, without having to wrestle with compositing and all that kind of stuff. So coming soon, data products built using machine learning in EarthEngine, but this land cover product should be coming very, very soon. And here's an example of that data product, what we call internally dynamic world, because it's changing all the time. This is just a map of the Bay Area, but it's a very detailed map, so high resolution, 10 meters resolution, and you get this for every Sentinel-2 scene. So very, very exciting there. Stay tuned for that, coming soon. Okay, what else is coming soon? What else is new? That was some coming soon stuff. What is actually already here that's new? Cloud projects. So there was an announcement that went out a couple of weeks ago on the developers list about how you can use cloud projects in the code editor. You can also use cloud projects through the command line or the Python API. All this is in the docs. But suffice it to say, when you go to the code editor, you'll have a new toggle on your username up here in the upper right of the code editor. And when you click that toggle, it's going to say, choose a cloud project to use. And so this is very handy. You can, excuse me, you can make your own cloud project or choose an existing one and route all your requests, all your EarthEngine requests through that project. You don't have to do this. You can keep using EarthEngine the way you've been using EarthEngine, which is just using a project that Google owns, you know, using an EarthEngine project to do your work. But it is very handy to use your own project. For one thing, you can organize assets easily under this project, and you can share those assets with your friends and collaborators. You don't have to share each individual asset. You can share those at the project level. You can set up special folders and have control over these assets very easily through your own project. So you don't have to create you know, you just create a project and then you can share all the assets from that project. You don't have to ask us to create a projects folder for you anymore. The other thing that you can do is you can monitor your requests. So I found this really handy for debugging and just sort of monitoring my applications. So once you start routing your requests through a project, you can go to the Cloud Console, go to the EarthEngine API. So this is just the EarthEngine API, and we give you a variety of metrics that you can look at. So you can track your responses by response code. So you know, I'm getting a bunch of good responses, but I'm also making too many. So I'm getting some 429s, you know, too many requests. I can track how long each request is taking. I can track how many errors that I'm making, and look at not only the traffic by, you can look at the response code by request, and you can also look at the latency by request. So long story short, all this is very handy for monitoring applications that you build with EarthEngine through the Cloud Console. You get 600 requests per minute, and if you run out, you can always ask for more. But this is another way that you can monitor the requests that you're making. So here you're looking at the response code and the latency by request. Here you're just looking at the number of requests that you're making, and you know, so my little app is very close to 600, which is good. You know, I'm making as many requests as I can, and I can sort of watch their fate with these other charts. So those are some advantages of using EarthEngine with a cloud project. You can monitor your requests, you can monitor the number of requests, and you can have this sort of much more control over how you share your assets. All this is in the docs, so you'll find in the docs there's this new cloud tab, and you'll see that it's still experimental. We're still figuring out how all this works, but we have all these docs here that explain hopefully everything I just said and much more. So you can start using a cloud project through the code editor, a Python client, or by making REST calls, and then there's a bunch of other pages here that explain the new world of EarthEngine through Google Cloud Platform. So please do check out those docs, and let us know if you go looking for something and can't find it. Speaking of docs, please read the docs. We get all kinds of questions on the dev list that are, you know, fairly easily answered by reading these docs. So we have a complete reference here, especially if you're an experienced programmer. Check out the debugging page and the best practices page. There's a bunch of interesting stuff in there that can really make your code more efficient. And so check out the docs, whether you're a beginning or an experienced user. Check out the docs and feel free to file feedback. We actually do read those. Sign up for EarthEngine. So this is our sign up app, and feel free to go there and enter your email. If you have an EDU account, that's better, because we recognize those accounts, and that will increase your likelihood of getting accepted for EarthEngine. We don't accept all applications, so please do fill out the application completely. And a bunch of code repos that are not in the docs, but I'm just putting them here. EarthEngine 101 is basically what we teach in our introductory workshop. EarthEngine 102 is about scaling your algorithms. This is a multi-temporal classification. EarthEngine 201 is sort of more advanced remote sensing concepts applied in EarthEngine. EarthEngine 202 is best practices. Here's some UI stuff, some change detection stuff, and the code that made that NDVI inspector app that I showed you previously. So feel free to check out these examples if you want. And that is all I have. I am right about at time here, so I will stop talking. And any questions?
All right, thanks so much, Nick, for that really interesting and also updated view of EarthEngine. I would say I actually started using it in 2013, but the world of EarthEngine has really transformed into something really new. I mean, cloud projects and all this is something I'm also learning, and it's really exciting to see the new apps that are being developed, and also the integration also of TensorFlow into, you know, doing the classification. Really exciting work. So we will open up this time for Q&A. And as mentioned, you know, we have a Slido link that we would request you guys to key in EarthEngine SG1, which is already in the chat box. We have one question in the webinar, and it is from Yi Xiang from the National Environment Agency. That is a public agency in Singapore that looks into the environmental issues here. He did ask if your stack of slides will be made available, because there are many useful hyperlinks. We could share them, but we first want to ask, you know, would it be possible to share them?
Absolutely, yeah. Let me just put up that first link here. This is the link to the slides, and they should be open. So feel free to grab those slides from this link.
Thanks so much, Nick. Yeah, I realized I was mute. Sorry. I just copy and pasted the slides also that link into the chat group. So everyone, feel free to have a look there. We have one question, I think also from Yi Xiang, who asked this question on the Slido. So he asks, how might users be able to combine private in-house data sets with open access Google resources for in-house app development? Is this through compute?
Yeah. So the way it works is that if you want to analyze your own imagery with EarthEngine, you have a couple choices. You can upload your imagery as GeoTIFFs to your EarthEngine private assets folder. So it's completely private to you. We can't see those data. We don't know what they are. You can share them with whoever you want, but they stay private to you. And you can upload that stuff there. You can also upload images into a cloud storage bucket as cloud optimized GeoTIFFs. So if you have a bunch of GeoTIFFs and you can turn those into cloud optimized GeoTIFFs, you can also store those in a cloud storage bucket and access those directly from EarthEngine. And you can find an example of how to do that in the reference example docs. The REST API reference docs. That'll show you how to get stuff out of a cloud storage bucket. But again, you have your own EarthEngine private repository, 250 gigabytes for free, and you can upload GeoTIFFs or shapefiles or CSV tables into there, and that is your private EarthEngine repository, and you can use that in conjunction with anything you find in the public catalog.
Great, thanks so much, Nick. Nick, would it be okay for Cheryl to share the Slido slides?
Absolutely.
All right, let's hope that this will be smooth. And thanks so much, Yi Xiang, for the question. We have another question from the Slido website. So any chance, this is from Anonymous, any chance of a desktop API software similar to the code engine?
Yeah, interesting question. Probably not. As I said before, the way it works is the code editor is really just a JavaScript client library running inside a web browser. And so in fact, when you get the Python client library, you download that. In some sense, the Python client is a desktop app. But all it's doing is it's taking your code, turning it into a request, sending it to EarthEngine. So you could build a visualization thing on top of that, and people do that with Node and with App Engine and with Python apps as well. But there's never going to be an EarthEngine. I'd never say never. There probably will never be an EarthEngine that runs on your desktop in the sense of like doing computations there.
Thanks, Nick. The second anonymous question is there going to be more comprehensive documentation for the Python API?
Well, let me put it this way. It will be more comprehensive than it is now, which is not very comprehensive. Apologies for that. We know that we've got a lot of work to do in documenting the Python API comprehensively, but we are working on it. And one of the things that we've been starting, I think we're almost halfway through now, is documenting every API method in the docs with both JavaScript and Python. So that's kind of how we're starting with the Python stuff, is at least having a code example for all the methods in Python for our users. The other place to check is the tutorials, the community tutorials. There are a bunch of Python tutorials in there. Yes, we will be working to improve our Python documentation in the meantime. But do see the Python tutorials and the code samples in the reference docs.
Thanks very much, Nick. Yeah, I guess, with progress, it always is in small steps. So it is definitely going to happen, but, in small steps.
Yes.
Do we have, but, with small steps, how much of a progress it has come since 2013. So pretty amazing. Another question, anonymous. So do we need to apply for a separate Google Cloud account to use cloud projects? And is there a fee for using it?
Yeah. If you are logging into EarthEngine with a Gmail account, then you don't need another account. You can use your Gmail account. You can use the same Google account that you use for EarthEngine to sign into Google Cloud. You don't need to pay to, as far as I know now, because it can always change, you don't need to pay to have a project. And I think you get some number of projects before they try to make you pay. But no, you don't need to pay to use EarthEngine with a Google Cloud project. But be careful, because if you store a lot of stuff in cloud storage, or if you use AI platform to host an expensive TensorFlow model, that stuff is not free, and you can get a bill for that. So you don't need a separate account. There's not a fee for using EarthEngine with a cloud project, but watch out, because there are parts of the cloud ecosystem that are not free.
Thanks, Nick, for that, and also for the heads up on possible fees. We have Akash Verma, who is asking a question. GEE seems to be slowly replacing my QGIS software. Any chance we get a more advanced map designer to create the final map for publishing?
Great question. Maybe. We're definitely, I can tell you that we're working on basic cartographic elements for map making, scale bars, legends, north arrows, this kind of stuff. And sort of that's the first step for us, is just having widgets in our UI library that you can use to make a map for yourself. I don't think we will ever get to the state of, say, QGIS or ArcGIS, which has sort of really mature, cartographic libraries for making layouts and maps and all this kind of stuff. EarthEngine is more of an analysis platform, and that's where we try to put our efforts is into the back end and the analysis part. And we are adding cartographic elements to the UI library, but I'm guessing that EarthEngine will never completely replace your desktop GIS in terms of map making.
Thanks, Nick. And then a question from Anonymous on recommendations for student-friendly courses or guides in exploring EarthEngine or geospatial datasets in general.
Yeah. We have one page in our docs. If you go to the community tab, and then there's an EDU item in the menu. And on that EDU item, there are some geospatial labs that my colleague Dave Saw and I put together for an introductory class using EarthEngine. And I think there are 5 or 6 labs in there, something like that. They're a little dated now, but they're still good. That is a fine place to start. And but I understand that you're going to have some other resources through this workshop. and I'm sure those resources will also be a fine place to start. But do see our the community tab in our docs.
Thanks, Nick, for directing us to the resources. We have probably time for about 1 or 2 more questions. So we have one question here from Nofaldi. Could you explain more about the NIC FI data in GEE data catalog?
Yeah, the NICFI data. I don't know very much about it. All I know is that those data are in the EarthEngine catalog, but you have to apply through Planet to use them. And I'm not sure what the requirements are, but if you meet the requirements, and you know, I think if you're a researcher or if you're doing work on deforestation, that kind of stuff, you should meet the requirements. But I really don't know. At any rate, if you meet the requirements, then you can access those data directly through EarthEngine, but Planet controls access to those composites.
Thanks, Nick. We do have one question under the web Q&A. Not sure if I explained this question correctly. Any plans to allow GEE as a data source for QGIS?
Yeah, you know, one of our power users, Gennady Dunkets, developed a QGIS plugin for EarthEngine, but I'm not sure of the status of that plugin. I think it still works, but I'm not sure. And you'd really have to check with Genna about that. The dev list would be a fine place to ask about how to use that QGIS plugin. That's all I know. It was developed by Gennady Dunkets, and it is not maintained by us.
Okay, all right. Thanks so much. I think just one final question. Akash Verma had asked for more examples of real-time monitoring apps for monitoring land cover change. You have any thoughts on that?
Yeah. If you want to make your own, see the land cover change detection repository that I posted in the slides there. There are some examples that would let you build your own. Coming soon will be Sentinel-2 based land cover time series. And that will be, you know, easy to turn into an app for monitoring land cover. Not quite ready yet, but coming soon. Stay tuned for Sentinel-2 land cover in EarthEngine.
That's very exciting. Thanks so much, Nick. I think that's all the time we have for Q&A. So thank you again, once again, Nick, for joining us from the US along the East Coast. It's really late for you right now. We thank you so much for giving us this wonderful talk. And, you know, all the best. And we're looking forward to more updates and new things that's coming up from EarthEngine. Thank you so much, Nick.
Great. Thank you for having me.
For the rest of our, good night to you. And it's still morning on our end and, you know, moving towards the noon time. So for the rest of our participants, please do join us for the parallel sessions. We will be having a short break right now, and then we will be going into our parallel sessions from 12:10 p.m. onwards. So do take a 10-minute break. Our first parallel talk will be, or rather it's all the same, but it's on the same timeline, but, you know, we have 4 different ones. We have one from Nicholas Murray looking at intertidal ecosystems. The next one, Mong Suan Yi, who is from Kumi Analytics, looking into machine learning with Google EarthEngine. Next. Jakarpong Tawala, who is looking at EarthEngine for United Nations Humanitarian Assistance Mission. And lastly, we have Keiko Nomura, who is at Climate Engine, and she'll be looking into deforestation, land cover change, and, you know, distinguishing that from other crop types. So with that, we would say goodbye to you for now. We will have a short break, and we'll be back soon at 12:10. Please go to your respective parallel talk session on Eventbrite, and we'll see you there. All right, thank you very much, everyone.
I'm ending the webinar. Bye, everyone.